Day 98 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. Hope you guys are ready to learn something today. But before we get started, guys, don't forget, bring your mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I need all of y'all, all of my bankers out there to the comment section right now. Drop 2 bank emojis in the comment section so we can run up this engagement and help get this content out to a broader audience and get more people interested in learning Swift and LeetCode as a whole, guys. Now, with that being said, I know why you're here, guys, and today we have question number 2373, largest local values in a matrix. The difficulty level is easy, but don't worry, we're going to keep the solution as simple and easy to understand as possible because we're all trying to learn here, and there's no point in writing code that nobody understands. So, let's see what the question says. It says you are given an n times n matrix grid. Generate an integer matrix max local of size n minus 2 times n minus 2 such that max local ij is equal to the largest value of the 3 times 3 matrix n grid centered row I plus 1 and column j plus 1. In other words, we want to find the largest value in every contiguous 3 by 3 matrix grid. Return the generated matrix. So let's break this question down. First, they want it of size n minus 2 times n minus 2. So that means we're just going to remove 2 columns and remove 2 rows. And this is what the output will end up looking like right here for this example. Then they want us to find the largest value in every contiguous 3 by 3 matrix in the grid. So in this example 1, we have, if we look for every 3 by 3 matrix, so we come down 3 and over 3, up 3. This is our first 3 by 3 matrix right here, right? If you pay attention, 6 would be in the middle. So, but we want the largest element in this 3 by 3 grid right here. And the largest element in this 3 by 3 grid right here is 9. So we put a 9 right here. Then we come over to this side and we do this 3 by 3 grid. Now if we look at this 3 by 3 grid, the largest element in this 3 by 3 grid right here is also 9. So we put a 9 right here. Then we come down here and we look at this 3 by 3 matrix grid, right? This 3 by 3 matrix grid, the largest element in this 3 by 3 matrix grid is 8. Y'all, it's right here. So we put an 8 right here. Then we come up, do the same thing on this side. This 3 by 3 matrix grid right here, the largest element in this 3 by 3 matrix grid right here is 6. So we put a 6 right here, and that's how we get our output 9986. Remember, guys, these represent each row in the grid, right? So this right here is row 1, this right here is row 2, this right here is row 3, and this right here is row 4. Or if it's a 0 index, it'd be 0, 1, 2, 3. But basically, if you stack all these on top of each other, you'll have this grid right here. And I'm just saying that so you guys will know where these numbers are coming from as well in the input. So that's the input. That's how it works. The input grid equals a 2D array of 9981, then another array 5626, then another array 8264, then another array 6222. The output is 9986. And remember, guys, this represents each row. So this 99 represents the 0 or the first row, 0 indexed or the first row, and this 86 represents the second row or the first index, 86 right here. So like I said, we just stack these on top of each other. That's how we get this right here. Then the explanation says the diagram above shows the original matrix and the generated matrix. Notice that each value in the generated matrix corresponds to the largest value of a contiguous 3 by 3 matrix grid. So like we were talking about, we want to find the highest value in each 3 by 3 matrix grid, which in this case would be 9. Then we move over and 9 again, and like I showed you guys earlier. Then, so let's look at this example because it's kind of tricky, but not really. It's just bigger. It's not really tricky. It's just bigger. But if you look, if this let's look at the input. We had the input grid equals the 2D array. First array is 1 1 1 1 1. Then we have 1 1. The second array is 1 1 1 1 1 again. Then the third array is 1 1 2 1 1. Then the next array is 1 1 1 1 1 again. Then the final array is 1 1 1 1 1 again. The output is 2 2 2. Then it's 2 2 2. Then it's 2 2 2, representing each row in the grid. And it says if you notice that the 2 is contained within every contiguous 3 by 3 matrix in the grid, guys. So if you look at this grid, let's look at the first 3 by 3. We go this 3 by 3, boom. If you look at this 3 by 3, the largest number in this 3 by 3 is a 2. So we put the 2 right here. Then we come over here, right here. This 3 by 3 grid again. The largest number in this 3 by 3 grid is 2. So we put a 2 here. Then we come over again. The largest number in this 3 by 3 grid right here. This grid right here, 3 by 3. Largest number is 2. So we put a 2 here. Then we do it again down here. 3 by 3 grid. Largest number is 2. Then we move over, do it again. Largest number is 2. Then we move over, do it again. Largest number is 2. And so on, guys. And that's how it works. Then we'd have to check the middle ones too. So this is a 3 by 3 grid as well. So we put a 2 right here. And we do it again right here. 3 by 3 grid in the middle. 2, 2. So yeah, just so you know, that's how it works. But every time we do a 3, since the 2 is in the middle, every time we do a 3 by 3 grid, the 2 will be included, and the 2 will always be the biggest number because the rest of them are 1s. So now that we understand the question, y'all, let's get into the code. The code is not that difficult at all. It's a little tedious, but it's easy to understand. And the first thing we are going to do is declare a variable called size. We're going to set that equal to grid.count minus 2, because remember, it says up here we're subtracting 2 rows and 2 columns. Then after we do that, y'all, we're going to come down here. We're going to declare another variable called result. We're going to set that equal to an array. And that array is going to have repeating, it's going to be repeating, but what's going to be repeating is going to be another array. So we're going to put another array, open up some more parentheses, and that one is going to be repeating 0 with the count of size. Then we're just going to come outside those parentheses, but inside the other parentheses, and put a comma, count size. So this is going to initialize our result into a 2D array, which we could use as the grid, guys. Then we are going to come down here, and we are going to say for I in 0 up to size. Open up the brackets. Then we're going to do the same thing for j and say for j in 0 up to size. Then we are going to come down here, and we are going to declare a variable called max local, and we are going to set that equal to max. Then we're going to open up the parentheses. We're going to say grid, open up the array brackets and put an I, come outside that, open up some more brackets and put a J. Then we're going to say comma. And then after that, we're going to say grid, open up the array brackets, put an I, come outside, open up more brackets and put J plus 1. Then we're going to come outside of that, and we are going to say grid again. And this time we're going to open up the array brackets, put an I, come outside of that, open up the array brackets again, and this time we'll put a J plus 2 this time, guys. Then we're going to come underneath that, and we are going to say max local, equals max. Then we're going to open up the parentheses again, and we're going to say max local. Then we're going to say comma, and we're going to say grid I plus 1. Then we're going to come outside of that, and we're just going to open up the array brackets and just put J. Then we're going to put comma. We're going to put grid again. Open up the array brackets, and this time we are going to put I plus 1. Come outside of those, put some more array brackets, and put J plus 1 as well. Then we're going to come outside that, and we are going to do the same thing. This time we're going to say grid. Open up the array brackets. We're going to say I plus 1. Come outside of those. Open up the array brackets and say J plus 2, guys. Almost done, but we're not done yet because we're going to do the same thing again. We're going to say max local. We're going to set that equal to max. Open up the parentheses, and we're going to say max local, comma. Then we're going to say grid. Open up the array brackets, and we're going to say I plus 2. We'll come outside that. We're going to say comma. Or no, not comma. First, we're going to put open up the array brackets and put a J. Then we're going to say comma. Then we're going to say grid. Again, open up the array brackets. This time we're going to say, again, we're going to say I plus 2. Come outside of that, open up the array brackets and say J plus 1. Then we're going to come outside of that, put a comma, say grid, open up the array brackets. We're going to say I plus 2. Then we're going to come outside of that, and we are going to say J plus 2. We're going to open up the array brackets, and we're going to say J plus 2. Then we are going to come down here, and we are going to say, result, and we're going to say, open up the array brackets, I, then come over, open up the array brackets again, say J, then we're going to come over there, we're going to say it's equal to max local, guys. And then we're going to just come down here, come right here, and we're going to say return result, guys. That should be all she wrote. Let's run it, make sure it runs smoothly. You know how this stuff goes. You can never be too sure, so we always run it before we submit it. And there it is. So no exact matches to call initializer var result array. So let's see what's going on here, guys. So we have array. It's a typo right here, y'all. Sorry, that should be repeating like that. So let's run it again. See how it runs this time. See what I'm saying? You can never be too sure, and it's accepted, y'all. So let's submit it now that we know it runs correctly, and see what happens after we submit it, y'all. And there it is, y'all. It's accepted. It's 57 milliseconds and beats 33.33% of users with Swift, y'all. Now, we got to get those numbers up, but we're just practicing here. We're still learning. We're all on our learning journey. So we'll get those numbers up further on down the line. But right now, this is what we have. And I feel like this is a good example that can be understood easily. So get one more look at the code. One more look at the code, y'all. And I will see you guys tomorrow for another day, another LeetCode problem. Hope to see you guys there. Peace.